4. Again, we're simplifying. That's pretty much what we're doing. We're simplifying when there's radicals that are in the denominator. And this one looks a little bit different because we've got 2 square roots that are in the denominator. And we cannot add those together. We can't take the square root of 5 plus the square root of 3 because they are not like terms. So we are going to rationalize the denominator, but we're going to do it a little bit differently. And this is called multiplying by the conjugate. And the conjugate is the denominator, except it's the opposite sign. So the conjugate of the square root of 5 plus the square root of 3 is the square root of 5 minus the square root of 3. So we're going to take the top and the bottom times the conjugate. Okay, on the top, we've got 14 times parentheses square root 5 minus square root 3. So if we go through and multiply that out, we've got 14 times the square root of 5 minus 14 times the square root of 3. Now in the denominator, you have to be careful here. You're going to have to FOIL this because you're taking a binomial times a binomial. Now the reason we're multiplying by the conjugate is we want all the square roots to go away, so hopefully that happens. If I do FOIL, the square root of 5 times the square root of 5 is 5. And your inners and your outers should cancel. So if we do our outers, square root of 5 times the negative square root of 3 is the negative square root of 15. Our inners, the square root of 3 times the square root of 5 is the plus square root of 15. And the positive square root of 3 times the negative square root of 3 is minus 3. Now notice that my O and my I, my outer and my inner cancel, which gets rid of my square roots. So in my denominator, I just have 5 minus 3, which is 2. So my next line would be 14 root 5 minus 14 root 3 all over 2. Now once again, we think we're done because we have our square root out of the denominator. But this can be reduced even further. And you just have to know that the 2, the 14, and the 14 can be reduced. You can't do anything with these square roots, okay? Because this is technically one term, 14 times the square root of 5. So if you reduce this, this becomes a 7, this becomes a 1. If you reduce this part of it, this becomes a 7, and this becomes a 1. So my 2 is going to become a 1, and my 14s are going to become 7s. So we end up with 7 root 5 minus 7 root 3. Once again, we can't actually subtract these because they're not like terms. Look at what's under the radical. We have square root 5, square root 3, so we just have to leave it as it is. Okay, to recap. If we go back to example 1, if you can actually divide the 2 square roots, you need to actually divide them and make them into 1. So the square root of 48 divided by the square root of 6 gave us the square root of 8, which we then simplified. In example 2, we learned how to rationalize the denominator, and these are the easier ones. We multiplied the top and the bottom both by the square root of 18. We multiplied the top and the bottom both by the square root of 24, x to the third, y to the 10th. In example 3, it was given to us as one big square root, and I separated it into 2, simplified it, then rationalized the denominator. And in example 4, our denominator looked a little different, and we did rationalize it by using the conjugate. which is the opposite sign. So I used the square root of 5 minus the square root of 3, which we FOILed and got rid of our square roots and ended up with our